So to wrap up Unit 2 with Lesson 5, we're going back to looking at evaluating trig functions, but this time we're going to be using our calculator. How can we use our calculator to evaluate trig functions? We are going to also look at reference angles, and then that will wrap up Unit 2. So notice that the sine of 32 degrees. 32 degrees is not an angle on our circle that we've identified and that we could determine the values of the 6 trig functions very easily. So I'm going to go to my calculator, and the first thing I want you to do is to look at your mode. I'm going to press mode, and you'll notice that my calculator is in radians, and I need it to be in degrees. So anytime your angle measure is in degrees, you need your calculator to be in degree mode. In fact, I always encourage you to keep your calculator in degree mode until we need to change it to radians. Everything on the ACT has always dealt with degree measure. So we just want to keep our calculator in degrees until we need it to be in radians. So I have arrowed down and I've now selected degree. I will second quit to get out of this. So now it's just a matter of pressing sine 32, close it. You do not have to use the degree symbol since the calculator is already in degree mode, and press enter, and we get a value, and keeping it to 4 decimal places, we'll write 0.5299. So 0.5299 is the value of sine of 32 degrees. And if we think about wondering if this makes sense, think about 30 degrees. 30 degrees is an angle on our circle. No, it's not. Well, yeah, 30 degrees is an angle on our circle. And if we think about the value of sine of 30, square root of 3 over 2, 1/2, the sine of 30 is 1/2. So it makes sense that the sine of 32 degrees would be 0.5299. All right, so let's go ahead and do a few more. We'll calculate cosine of 102 degrees. So cosine of 102, close the parentheses, press enter, and our value is negative 0.2079. And I'm going to ask if it makes sense in terms of the sine. If you think about where 102 degrees is, 102 degrees is in quadrant 2, and the cosine values of the angles that are in quadrant 2 are negative. So that value does make sense. Now let's talk about identifying or evaluating cosecant of 92 degrees. Many times we want to think that we need to use the like the inverse feature on our calculator, but that is not what we use when we evaluate or want to find the value of cosecant of 92 degrees. Cosecant, you have to remember, is the reciprocal of sine, and so to calculate cosecant of 92, I need to calculate 1 divided by sine of 92 degrees, and I will close it. So the idea that cosecant is the reciprocal of sine is what's going to help you out here. So press enter, and this value gives us 1.0006. Okay. All right. Which again makes sense. This would be in quadrant 2. Sine is positive in quadrant 2. All right, now for the secant of 89 degrees. How do we go about evaluating that? Again, secant is the reciprocal of cosine, so I would take 1 and divide it by cosine of 92, close it, degrees. and enter. And we get negative 28.6537. So we have ways of, the calculator will actually evaluate the trig functions, but they're always going to give you answers in terms of decimals. And that's okay, except for when we want to utilize our traditional, or not our traditionals, but those angle measures that are the ones that are the most common. So you have to be able to use your circle to identify the angle measures for those angle measures, but you also have to know how to use your calculator to evaluate it also. All right, so let's go ahead and finish these out. Tangent of 335, I just have to push tangent 335. I will close it, and that value is negative 0.4663. And then for cotangent of 144 degrees, that's the cotangent is the reciprocal of tangent, so I will do 1 divided by tangent of 144 degrees and press enter, and that value is negative 1.376. All right, so now we'll move on to angles that are in radian measure. And since I have several angles that are in radian measure, I will go ahead and change my calculator over to radian mode. So go back to mode. I will go down to radians, press enter, and now my calculator is in radians. So if we think about pi over 4 is an angle measure that is on our circle, and the cosine of pi over 4 is the square root of 2 over 2. But what would that be as a decimal? Well, I could go ahead and calculate the square root of 2, and I need to get out from under the radical and divide by 2, and I will enter, so I get 0.7071, or I'll clear that off. I can, now that I've put my calculator in radian mode, I can type in cosine of pi, which is above the caret key, divided by 4, and close. And when I push enter, I get 0.7071. And I can do the same thing for, even though a lot of these angles, if not all of them except for pi over 7, all of these angle measures are on the circle except for 5 pi over 2 and pi over 7. I still want us to be able to know how to evaluate trig functions regardless of what the angle measure is using our calculator. So secant of 7 pi over 4, if we will take 1 and divide it by cosine of 7 pi over 4 and close it, we get 1.4142. 1.4142. Excuse me. All right. And what quadrant would 7 pi over 4 be in? Quadrant 4, I believe. 7 pi over 4 is in quadrant 4. And tangent is, no, not tangent, secant and cosine are both positive in quadrant 4, so that does make sense. All right, how about sine of 5 pi over 6? So sine of 5 pi over 6, enter, is 0.5. In fact, where is 5 pi over 6? So here's pi over 6. This is 5 pi over 6. This ordered pair is the square root of 3 over 2, 1/2. 5 pi over 6 is also going to be 1/2, so it makes sense. All right, cosecant of pi. If we think about this, let's think about where pi is. pi is here, -1, 0, and has the ordered pair -1, 0. If I want cosecant, I have to look at sine. Well, sine of pi is 0, so what do you suspect cosecant of pi should be? All right, well, let's see what the calculator tells us. So 1 divided by sine of pi, and we get error divided by 0. So what that means is cosecant is undefined. Because remember, the reciprocal for sine, if sine of pi is 0, the reciprocal of that is undefined. How about tangent of 3 pi over 2? So tangent of 3 pi divided by 2. And that's, well, what in the world? Let me clear that off. So tangent of 3 pi divided by 2. So now we see where it says quit or go to or whatever. We still have an error and it says domain. Well, that's an interesting scenario there. It still means that tangent of 3 pi over 2 is undefined. And if we think about that, 3 pi over 2 has an ordered pair of 0, -1, and tangent would be -1 over 0, which is undefined. So again, I'm not really sure why cosecant gave you a domain error. No. I'm not sure why cosecant, the calculator gave a cosecant of pi as can't divide by 0, and tangent is undefined. It had a domain error. Regardless, though, both of those are undefined. Okay, what about cotangent of 5 pi over 6? So if I want cotangent, I have to take 1 and divide it by 5. Nope. Let me try again. 1 divided by tangent of 5 pi divided by 6. And I will close the parentheses and enter. And that value turns out to be -1.7320. So hopefully by now you get the hang of it, of how to use your calculator. The key is knowing that you have to put your calculator in radian mode when evaluating trig functions in radian measure, and you have to make sure, excuse me, that your calculator is in degree mode when your angles are in degrees. All right, so we'll finish out sine of 5 pi over 2. So sine of 5 pi divided by 2, that turns out to be 1. And tangent of pi divided by 7 equals 0.4815. 0.4815. All right, so hopefully that gives you a good feel for how to use your calculator to evaluate trig functions. So now I want to move over to finding angle measures on the interval where alpha is between 0 and 2 pi that would have the given trig value. So in other words, secant of alpha equals the square root of 2 square root of 3 over 3. What I'm looking for is the angle measure that has a secant value that is 2 square root of 3 over 3. So we're looking for the angle or angles between 0 and 2 pi. And so this is where I'm going to go back and revisit our circle. Our circle, cosecant, I'll tell you what, just for reference, so I don't have to necessarily redraw it every time. My circle, this is ordered pair is square root of 3 over 2, 1/2. This is square root of 2 over 2, square root of 2 over 2. And this angle would be 1/2 square root of 3 over 2. So if I want secant, and I need secants, the secant value to be 2 square root of 3 over 3, then I want to find the angle where cosine of alpha is the reciprocal of 2 square root of 3 over 3. And so that would end up being the square root of 3 over 2. And so which angle in quadrant 1 is cosine square root of 3 over 2? And that is this angle right here. In radian measure would be pi over 6. So hang on just a minute. Cosine square root of 3 over 2. Let me make sure I did that right. So alpha then would be equal to pi over 6. And then in what other quadrant is cosine positive square root of 3 over 2? So first quadrant, positive, positive. Second quadrant, negative, positive. Third quadrant, negative, negative. Fourth quadrant, positive, negative. Okay, so in quadrant 4, cosine and secant are both positive. So my angle will be pi over 6 and 11 pi over 6. So secant is the reciprocal of cosine, and the reciprocal of 2 square root of 3 over 3 is the square root of 3 over 2. So I'm looking for the angle where cosine has a value of square root of 3 over 2, and that is at pi over 6 and 11 pi over 6. All right, what about what value or what angle or angles does cosine have a value of negative 1/2? Okay, well in quadrant 1, I'm going to identify the angle that has a cosine value of 1/2, which is pi over 3, but my angle measure needs to be negative. And cosine is negative in quadrant 2 and quadrant 3. So alpha has to equal, it's in the pi over 3 family, and in quadrant 2, we have 2 pi over 3. And in quadrant 3, the pi over 3 angle is 4 pi over 3. So 2 pi over 3 and 4 pi over 3 are the angle measures where cosine is negative 1/2. All right, cosine of alpha is square root of 2 over 2. Hopefully that one is an easy one to remember because it's the square root of 2 over 2's. Alpha has to be pi over 4. And then cosine is positive again in quadrant 4. And the pi over 4 angle in quadrant 4 is 7 pi over 4. All right, then for tangent of alpha is negative 1. So tangent is 1 or negative 1 at the pi over 4's. Because remember, at pi over 4, you have the same value for cosine and sine. So tangent would be a 1 or a negative 1, depending on the quadrant. And I want to know what angle measure tangent is negative 1. So it's a pi over 4. But for tangent to be negative, we have to have the pi over 4 angle in quadrant 2. So that would be 3 pi over 4. And tangent is negative 1 also in quadrant 4. So that would be 7 pi over 4. Is that right? So 3 pi over 4 and 11 pi over 4. 7 pi over 4 rather. Okay, now what about cosecant of alpha has to equal negative 2? Well, cosecant is the reciprocal of cosine. No, it's not. Cosecant of alpha is the reciprocal of sine. So if I want to find the angle where cosecant is negative 2, I just need to find the angle where sine is negative 1/2. So sine is 1/2. in quadrant 1, sine is 1/2 at pi over 6. Yeah, pi over 6. And sine is negative in quadrant 3 and quadrant 4. So the pi over 6 angle in quadrant 3 will be 7 pi over 6, and in quadrant 4, 11 pi over 6. So 7 pi over 6 and 11 pi over 6 are the angle measures where cosecant has a negative 2 value. Okay, what about where what angle measures sine is negative square root of 3 over 2? Well, sine is negative square root of 3 over 2 at the pi over 3 angle, and sine is negative in quadrant 3 and 4. So the angle measure for alpha that has a sine value of negative square root of 3 over 2 will be pi over 3. So that's what, 4 pi over 3 and 5 pi over 3? So 4 pi over 3 and 5 pi over 3 are the angle measures where sine is negative square root of 3 over 2. So this alpha, anytime you have a trig value, trig function of an angle measure, and the angle measure is unknown, that is what you're looking for. So if I want to know where cosecant of an angle measure is undefined, then I'm looking to find where sine of the angle is the reciprocal of undefined, and the reciprocal of undefined is 0. So let's think about this. So from 1, or at angle 0, sine is 0, so alpha is 0 at angle 0. Then negative 1, 0, also at pi. And the directions tell us that we want all the angles between 0 and 2 pi. So we are going to come all the way back around and pick up the 2 pi angle as well. And the only reason why we're using all three, even though 0 and 2 pi do have the same terminal sides, is we're including the 2 pi because we're told to. All right, and then a couple more where for what angle measure alpha is sine the square root of 2 over 2. Well, that's at the pi over 4 angles. So alpha equals, sine is positive in quadrant 1 and 2. So that would be pi over 4 and also 3 pi over 4. Tangent of alpha equals 0. So for finding the angle measure alpha where tangent is 0, I need this to be sine over cosine, and I need it to be 0 on top divided by, in this case, the angles on our circle would be 1. So on our circle, tangent is 0 at this angle measure, 0, at pi and also 2 pi. So tangent of alpha is equal to 0. The angle measures that have a tangent value of 0 are 0 pi and 2 pi. All right, and then finally our last angle measure, or our last example, I want to find the angles where secant is 2 square root of 3 over 3. So if secant is the reciprocal of cosine, so I'm looking to find the angle or angles where cosine is the reciprocal of 2 square root of 3 over 3, which is the square root of 3 over 2. And so going back to our circle, cosine is square root of 3 over 2 in quadrant 1 at pi over 6. So one of my angles will be pi over 6, and the other, where is cosine positive, the other angle where cosine is positive is in quadrant 4. So that's pi over 6 and 11 pi over 6. So you now should be able to evaluate a trig expression that is missing the angle measure. You're looking for an angle measure that has a given trig value. So that will conclude this portion of lesson 5. You should now be able to work through your assignment as well.